Start. Good morning, everyone. Myself Sagar. I am from batch 9. Our batch members are Karan Kalyan, Abhishek, Nagesh. Uh, our we are under guidance of T. Sheshagari, assistant professor. Our mini project name is Augmented Reality in Real Time using Machine Learning. Let's talk about abstract. Augmented reality has become a useful tool in many areas, from space, military, and gaming, and industries like shopping malls and etc. This is a theoretical principle from many years, and now it became the real world. Augmented reality is almost exclusively used in high budget solutions. However, in last few years, we could raise popularity in this project, like we have seen in mobile phones and applications like applications. Our project is aimed on developers who consider development of an augmented reality applications for the mainstream marketing. Usage of this existing image processing software library could a significant cut down of the development costs. Implementation of the key parts of the augmented reality application is done using OpenCV library. Introduction. Augmented reality is an interactive experience of a real-world environment where the objects that reside in the real world are enhanced by computer-generated perceptual information. With the help of advanced AR technology, the information about the surroundings real world user becomes interactive and can be digitally manipulated. In this image, we can see a peacock on a road. That is in a mobile phone. This is a mobile phone application gaming. Next, sanitary. In medical, AR is become a useful tool like surgery. We can hologram the part of a area, and we can reflect the damage or surgical part, and how to how to do surgery. Like, this is the interior design. A mobile phone application is developed using AR application. In this, the object what you are purchasing is object augmented on a floor where you want to keep, like this where you want to place, like how you want to design your interior. Next, architecture. In last few years, we are if you want to build a building, we will construct a model, like building means we construct first a model, and then we show to the customers, like this it will appear. But nowadays, in augmented reality, if a video is displayed, means a real world footage is displayed on surface of the target image, and this video appear. In fashion, a display and camera is placed on a mirror, and on the device, all costumes, like whatever they want, it will be placed. They will choose whichever they want, and they try. without going to the trial room. They can purchase through online also. Next. From here, Abhishek, my friend Abhishek will continue.
Good morning, everyone. Myself Abhishek. I'm gonna tell you about the existing system versus proposed system. Existing system is nothing but it is a QR code based system where the existing technology or the previous technology uses markers. Markers are nothing but the QR code which we give to the input. Markers also have several weaknesses, doesn't work if partially overlapped. Marked image has to be black and white. It does not allow if the marker is in other colors. And most of the markers are in black and white, colors. And proposed system is nothing but a markerless system where the image would be displayed in any real-time objects at any real-time objects. These are the strong sides of the markerless AR approaches are it can be used to detect real-world objects. Works even the target is partially overlapped. Target can have any form and texture. So next we'll discuss about the domain. Domain of a mini project is machine learning. Machine learning is a part of artificial intelligence. Machine learning is a part of artificial intelligence. Machine learning is a study of computer algorithm that improves automatically through the experience and by the use of the data. And the library we are using in our mini project is OpenCV. OpenCV is a cross-platform library using which we can develop real-time computer vision applications. Basically, it focuses on video capturing, analysis, and processing. Next, we'll be discussing about the artificial infrastructure. Artificial infrastructure is nothing but the process how the project is done. At the start, we'll initialize the project and we'll show the input to the camera stream. And the camera would be streamed and it will extract the features. It will extract the features and it will match the features with the extracted input. And then it will calculate the similarities of the input image, and it compares the similarities like size, shape, and etc. And it goes through the geometrical registration. It goes under the geometrical registration and it displays the AR, means it gives the output, and it is been tracked by the output. And next part class diagram will be discussed by my teammate Karan. Thank you.
Hello everyone, I'm Karan. I'm going to discuss about class diagram. In class diagram, in the code we are using ARP pipeline, and in that ARP pipeline we are using camera calibration and pattern tracking information and pattern. What is mean by pattern? Pattern means it is a video or an object that has the size and data which has the matrix points and key points, description and points of 2D. And camera calibration. Camera calibration is nothing but we are calibrating the camera. It means autofocus or the adjustment of size and everything. And what is pattern detector? Pattern detector means it is query key points and query descriptions, matches and key matches, grayscale, and pattern detector using CV, pointer destruction and feature detection. These are all included in this pattern detector. Next, we are going to discuss about implementation of the augmented reality in real-time using machine learning. First, we used to start the camera and then convert the input image to grayscale. Then we will detect the feature and key points from the interesting zones in the image. We exclusively use here ORB feature detection algorithm. It means we detect the key points and features from the image which we have given in the input to, and that will be detecting by using the ORB feature detection algorithm. Here ORB means oriented, fast and rotated brief. Then we match the features and key points by using FLAN based matcher algorithm. FLAN means fast. FLAN means fast. Wait a second. FLAN means fast approximate nearest neighbor searches. Then next we prepare the geometry by computing the descriptors to augment the things on the interesting region by using homography refinement. Homography refinement is nothing but the image or video should be placed on the uh, given object. It means it may be QR or it may be real-time object that should not match with the background colors and background surfaces. It should be fall on the given input image, that is marker in existing system, and in real-time system it is a real-time object. Finally, we augment the requirement graphics on the target location of the input image. Next, the conclusion is overall, the markerless based augmented reality was a huge success. In comparison with marker-based augmented reality systems, the proposed markerless augmented reality system has two main advantages. One is in installation of artificial makers which affect the landscape view is not required. And the other thing, the user does not require to constantly capture an artificial maker while tracking. Hence, it provides users with more freedom of movement. This is the video of output of existing system. Background is the marker and the input that marker is given to the input one, and the video is the input two. That video is falling on the marker only, not on the surface of the card or the background human being. This is the conclusion, and next other part will be continued by the Nagesh.
Hello, good morning. My name is Nagesh. I'm going to tell you about the future works. This study showed that it is necessary to precisely identify the positional relationship between the virtual objects and real world scenes. But in 3D objects, we need to improve the precision of registration and tracking as future work. In addition, it is possible to use this AR system at only the route in which the photographs are taken. Hence, when using the AR systems in other routes, the camera parameters are required to adjusted. Further studies, we needed in order to solve these challenges and actions. Thank you. Have a nice day.